Hey, what's up, Pre-Cal 12? I am alone on this Tuesday. I hope that came through there. I hope this is coming through. Yeah, I'm all by myself, but hey, you know what? It's going to be a great time. We're going to do our study session together. Yeah, we're going to be rocking. So get out your review, get out a pencil, pen, your calculator, and review sheet, your formula sheet as well, and let's get rocking. All right, our inaugural shot before. It's going to be a longer one. Here we go. Ah, man, it's live, so I can't change that, but we're going to get it going anyway. And here we go. I'm going to kind of pull this over to this side. And so we're going to get going just on number one, and we'll get started on some of these. Some of these that are here. Okay, let's get this hook going. Turn my music down here. And I want to make sure that this is still coming through. Just want to make sure the YouTube video, because it kind of came out, said some weird things on me. Sweet. Okay, we are live, ladies and gentlemen. We are ready to roll. Okay, so if you can, again, get out your stuff, and we are going to get rocking. I'm even going to get my calculator here, and we're going to get started on these. Couple things to remember. Numbers 1 through 7 are the law of sines and cosines. I'm going to come back to those in just a second, but the number one thing that people told me was, Coach, please go over vector stuff. So I want to go ahead and start over here and then move my way towards the front, okay? All right, so the first thing that I want to mention to you is number 9. We remember that a vector of 3, -2 can be drawn in a way that goes 3 to the right and 2 down, right? So we have the initial, it goes through my terminal, and there I am, right? And so a couple of things that they want me to figure out here. They want me to figure out a vector that goes the same direction, except now only goes a distance or magnitude of 1. That's what a unit vector is, okay? We can do that by taking the regular vector that we've been given, 3, -2, and dividing by whatever the magnitude is. So I did this one in class, so I'm going to go fairly quickly through this. The magnitude of this would be the Pythagorean theorem, which would be 3 squared plus -2 squared. And then take the square root of that. Okay, and that's, again, remember the hypotenuse is always my magnitude, so just a heads up. So this would be the square root of 13 here, and we would put that underneath the regular vector. So if I was to rewrite this in terms of what the unit vector would create, it would be 3, -2 divided by the square root of 13. And then the square root of 13 would go to both of the sides. So this would be 3 over square root of 13, -2 over square root of 13. And if I was to kind of rewrite this, I would rationalize it to be where it would be 3 square root of 13 over 13 and -2 square root of 13 over 13 as well, okay? And again, we call that a unit vector, which means that this vector has the same direction as 3, -2, but instead, if I did the Pythagorean theorem here, we would have a magnitude of 1, okay? Also remember that anytime that I do 2 lines, such that B with 2 lines here means magnitude. So just a heads up on that one as we go. The next part that we are going to go to is find the angle between the 2 vectors. So if I were to draw this, I would have 3, -2. You don't have to draw it, but I just want to show you. And then we'd have -3. And then we'd have 8, which would be way down yonder here. All right, so the angle created would be this angle right here. And we could actually solve for this angle using the formula that's over on this side, okay? Now, this is the formula that's been given to you. The one that I used in class is similar. We just divided by the magnitudes of A and B, right? So really the formula would be the dot product of the 2 vectors. I'll use U and V since we've got it. The dot products divided by its magnitudes of each of these, okay, equals cosine of theta, okay? Now, remember with magnitude, when we look at the magnitude of U, we could find this by creating the little 90-degree angle for, we'll say this is u, right? And we could say that 3 squared plus -2 squared equals c squared, right? Or we could just say, if we want to, that the square root of 3 squared plus -2 squared is our magnitude, which would be the square root of 13, okay? So the square root of 13 is u with 2 lines underneath it. Now, what about v? Well, v, the magnitude's created on this one by doing the same thing, the square root of, by creating that 90-degree angle, right? It should be -3. This would be, hold up, I think I said should be, it shouldn't be here, my fault. It should be right. My apology here. This should be -3, 8, which should be like towards this direction. So we're trying to actually find this angle here, but it doesn't change anything. It just kind of changes the picture that I put here. But as far as how I execute it, I would still do -3 squared plus 8 squared. And there we would be. So this would be 9 plus 64, which is 73. And then I would square root it to get the square root of 73 as my vector v that's there, okay, for the magnitude. So the only thing that I've got to kind of use here is find what the dot product is. And I'll do that by kind of drawing an arrow down here. Remember, the dot product is the x's multiplied together plus the y's multiplied together. So this would be 3 times -3 plus -2 times 8. Okay, so this would be -9 minus 16, which would be -27. And there you are. That is the dot product of u and v. Okay, and there we are. So what we would then do is then with -27, we would simply plug it into the formula that we have up here. So we would say, okay, this top part is -27 divided by, we talked about the magnitude of u is square root of 13. The magnitude of v is square root of 73. And we'll set that equal to cosine. I'm going to kind of minimize that here, my fault. We'd set that equal to the cosine of theta, okay? Now, in doing this, I would actually, if I were you, I would say, do this bottom part first and then divide -27 by it. So if I were to plug this in, and I'll kind of take out my good old calculator there, the square root of 13 times square root of 73 would be 30.8058. And then I would take -27 divided by that. You could even do just by your answer. So -27 divided by 30.8058. Okay, hold up. All right, perfect. And I get this here, this was like -0.8764. And then I could just do the cosine inverse of this on both sides. Once I get that in my calculator, the cosine inverse of that would be, I got theta, because once you do that, you get theta by itself. And so theta is the angle that equals 151.22 degrees, okay? And that would be the angle between the two vectors that was created there. Number 8, remember that this is x2 minus x1, comma y2 minus y1. The reason why is these are not vectors in and of themselves, but it actually, they're initial and terminal points that are created. Where the initial is where I start, the terminal is where I'm heading, okay? All right, the next one's number 11. These ones were the ones that I really wanted to hit on, numbers 11, 12, 13 in here. 11 says you're on a fishing boat that leaves its pier. I at least want to set this up. So you're on a fishing boat that heads, that leaves its pier and heads east, okay? All right, so it heads east. Here's our vector that's created. After traveling 25 miles, okay, and it does that, there's a report warning of rough seas directly south. So the captain turns the boat and follows a bearing. So right here, I want to make sure you understand, like, we've stopped here, right? So what we've got is we've got our new location of now applying the south 40 degrees west. So we're going to go south 40 degrees to the west side. Okay, so this would be 40 degrees here, which would make this right in here 50 degrees. Okay. All right, so we've got that there. And it says for 13.5 miles. Okay, so watch this. This would be 13.5 miles. So what we've got here is then it asks the question of drawing the picture, which we've already done, right? So went east, then we stopped. We went south 40 degrees west, right? Okay, so then we draw it out, which would give me that this would be 50 degrees attached to the x-axis. And then 13.5 miles would be the distance that the boat would travel down towards the bottom left. It then says, how far from the boat's pier were you? Well, the boat's pier was here, right? So we could actually solve that by saying, get a different calculator here. And there we are. We're going to try to find that distance. Well, this would be, I know this side length, 25 miles. I know this angle, and I know this side, right? So with the side angle side, we could actually solve for the opposite side that's here, which we call x, okay? So how do we solve for x? We could solve for x by, we could actually solve for the full triangle, couldn't we? By saying, okay, how could I solve for this full, how could I have done that? Well, this is the original spot, right? So the side angle side, we could say, okay, so we're going to solve this for x, right? So we could say x squared equals 25 squared plus 13.5 squared minus 2 times 25 times 13.5, okay? Cosine of 50 degrees, okay? Now let's just try to break this down. And again, we don't want to throw all of this together, right? We don't want all that together. We want to do it kind of little by little. So we could do 25 squared plus 13.5 squared. So let's do that. 25 squared plus 13.5 squared. This is 807.25. And then 2 times 25 times 13.5, we would say is 675. So this is minus 675. And then this is where we could put cosine of 50. Now, since we're not solving for the angle, which is kind of nice here, we could just say, oh, okay, we could just put that in our calculator. So 675 times the cosine of 50. So this is 433.81, or 88, I'm sorry. And then we take 807.25 minus this. So 807.25 minus 433.88. Okay, and we get 373.37. That equals x squared, square root both sides. And there we are. We'll end up getting 19.32. And there we are, the 19.32 miles. Okay. And again, that would be what x would be equal to. This is basically the same as with law of sines and cosines. The only difference is now we're attacking it, trying to find what the side lengths are in terms of the context of the problem, right? So then we could say, okay, the question in blue, this is part C, by the way, is from the original spot, so right here, what was the bearing that we could have taken to go directly to where we ended up right here? Well, we can do that by solving for the angle here, and we could do just the law of sines, right? So we'll name this big A, okay? So we'll say sine of big A over cross would be 13.5 is equal to the sine of 50 over x, which in this case was 19.32. So then we could cross multiply to get 13.5 sine of 50 equals 19.32 sine of big A. Divide by 19.32. There we are. You're Gucci, y'all. You're Gucci. Keep it going. And we would say, and I would actually break this down, y'all. I would say this, put it in, 13.5 sine of 50 divided by 19.32, and then do the sine inverse of that. And this is where I would get big A is equal to 32.36 degrees. And you could, just because I've said it, you could have just said 32 degrees and been good. So if this is 32 degrees, that would give you the majority of it, but we also need a bearing, right? So a bearing would be southeast because we're going from here to here. So we're going southeast. And then the angle for the bearing would be from the y-intercept, which would be 32 subtracted from 90, which in this case would be 58 degrees. So south 58 degrees east. Okay. Very nice. This is a good one. That was a really good one. I hope that made sense to you on that as we broke it down. Couple of things on that. Write them in component form. These things, don't miss these things, okay? So W equals 3,9. Make sure you write all of these. This is exactly like the test question, okay? Maybe not the exact numbers, but the same idea. W plus V, make sure that you add those up. So if I did, I would say 3 plus -5, which would be -2, 9 plus 12 is 21. Okay, so you can keep them in component form. If I did 2W minus V, that would literally be 2 times 3, 9 minus -5, 12. Okay, so what would we do is we would distribute kind of 2 in for both to get 6, 18. And then minus would go into both actually as well. So we would say plus, we'll distribute the negative in 5, -12. And then we combine the x's and y's to get 6 plus 5, which is 11, 18 minus 12, which is 6. And that's how we get 11, 6 there, okay? Again, I'm doing these quick. These ones are easy because you literally distribute. These are a little tougher because the dot product, we use W and V. And remember, we multiply the i's or the first values together to say that it's 3 times -5 plus, then we do the y's, 9 times 12. Okay, so this would be -15 plus 108. So this would end up being 93 as my total for part D here. Magnitude, I feel pretty good about that. Just make sure that when I take the square root, you keep the negative inside the parentheses. So for V, if I did the magnitude of V, 2 lines around, it's the same thing. That would be the square root of -5 squared plus 12 squared, okay? And just make sure you do that as well. And then the angle between the two vectors, you go ahead and try it. But remember, that's the dot product of UV divided by the magnitude of U times the magnitude of V equals cosine of theta. And then I just plug in what I knew from up top here, okay? So like 93 would go in for the top. Once I found the magnitude of U and the magnitude of V, plug it in. And then remember, take the cosine inverse on both sides, okay? Show that work that's there. Okay, we are rolling right now. It is, man, we are flying. So we are going to keep it rolling. I'm going to take a little sip of water here. And you can do the same. I love talking to myself, by the way, in my classroom. It's funny because the glass walls over there, or glass doors, they kind of, people look at me strange, like, Coach, is Coach okay, or whatever. So I'm doing this for y'all. Okay? Gotta love it. Okay, number 13. By the way, while we're at this spot, I'm going to be, by the way, I have a lot of clout. I've been told that. I don't know if that's true or not, but yeah, we are rolling. The bonus question is a good one, where we have the airplane in the wind and we equal the ground speed, okay? Where it's the airplane, I'll do this. Plane plus wind equals ground speed. Here's the deal on that one. We just did one of those in class. I think I podcasted it on section 6.4, I think. Yeah, it was like 2 days ago. It might have been even yesterday. But take a look at that one and see if you can figure that out. The one thing I will tell you on the plane part, when you create the vector, is if it is headed at 210 degrees, That's here, right? So that's 210 degrees. At 340 miles per hour, right? There's that. What we've got here is we got a right triangle, right? Where we're trying to solve for I and j. But just remember that both of these are going to be negative, okay? So when you combine that, that's something to keep in mind. And then also this idea of wind, if this is the wind, so this is the plane, right? So if the wind is over here and it's coming from the west would mean it's going this way, right? So we would say that it's going from the west towards the east, and then that says that 50 miles per hour, right? The beauty of this one here is because it's on the x-axis, we actually already know the I and j here because there is no j, right? There's no j here, but there is a I, and it's 50, and it's positive because it's going in the right direction. So you could say it in composite form. Traditionally, we would say that vector w would equal 50i plus 0j. Cool. And over here, this would be vector p or v or whatever. And to find what I and j is over here, we would do cosine and sine. So this would be 340 cosine of, and you could even use this angle or you could use this one, but just remember they're negative. So 340 cosine of 210, and that's my I, and then plus 340 sine of 210, and that's my j, okay? And remember that these are plus, but they should both be minus as I take it out because it's in the third quadrant. And then I'll combine them together to get my ground speed. And then once I get my ground speed vector, I would find the direction and magnitude of that. I do a Pythagorean theorem and inverse, okay? Do this for me. That one's one. If you need some help on that bonus, come on in and get some help with me on that because I would love to walk you through it. All right, let's go to part A. Draw the graphs of the two vectors that are above. All right, number 13. It says there's two vectors. We're going to say vector u and vector v, okay? Now, what we've got here is we have two forces that are being pulled, right? So two things are being pulled. We have vector u pulling 90 pounds at 40 degrees, okay? 40 degrees, and the magnitude is 90 pounds, right? A force, because again, magnitude could be force, it could be miles per hour, which is speed. It also could be distance. So any of those is our magnitude. Then we looked at vector v, which would be 120 pounds at 120 degrees, okay? So we got 120 degrees. So here we are. And then this is 120 pounds, okay? Awesome. One thing, again, as I create this is we do have a triangle created, right? We see that triangle where this is I and this is j. Just like I said earlier, same thing going down. This is I and this is j. I would put a little sign here. This is going to be positive. This will be positive. J will be positive, but remember, I will be negative because it's going to the left, to the left. Everything about to the house to the left, in the closet. No, 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 no. Isn't it like, you must not know me, you must not. Yeah, something like that. Wasn't that Rihanna that sang that? I think so. Yeah, that's what it was. That's who it was. Cool. All right, so as I look at this, I'm looking at the vectors that are created with u and v, okay? Now, in each of these, we're going to treat them as separate, but then we're going to combine them together. So if it said find the I and j form, which, by the way, this is nice, I actually break it down like this for you on the test, okay? So each part is important to kind of attack here. So it says find the I and j form of the forces. So I can find the I and j of the u forces by doing the cosine first, right? And how do I find the I using cosine? Well, I can do that by saying cosine, this comes down here, right? Cosine of 40 degrees equals the adjacent, which is I, over hypotenuse, which is 90. So then we multiply by 90 on both sides, 90. And we would get 90 cosine of 40 equals I, okay? So I'm going to put that in. Goes with I. And notice that in this one, what would go with J? Well, I think you can kind of see that sine would go with J. So this would be plus the same thing, except sine would go with J. The beauty of this is that when we do I and J, cosine and I go together and sine and J go together, where the hypotenuse is on the outside and the angle is on the inside. For the V part, we remember that cosine right over here would be 120 as the angle and 120 as the magnitude. So 120, which is the magnitude, cosine of 120, I, plus 120 sine of 120 goes with J. Okay? But remember, highlight or do something that represents that once I do this, that my I should be negative as a result of the n, okay, when we plug it in. Okay, so here we go. Plug all these in and get it in terms of I and J. So 90 sine of 40, 90 cosine of 40. Cosine, here we go. We got U is equal to 68.94. And each is a checkpoint, right? Each is a checkpoint that you're trying to just kind of check off there. Perfect. V, let's do this one. 120 sine of 120. 120 cosine of 120. So this is, I did in fact get a negative, so I'm good there. So I can kind of check that off. This one would be positive at 103.92. Okay, J. All right, so I've got part one. I've got part two because I've actually found the forms. It then says find the resultant. Well, that means that if I were to use both of these forces up here, okay, all right, that took all of my energy to get that high. No laughing. I hear that through that screen. I hear you. I hear you on that one. I could actually find the resultant by just combining them together because it's as if two forces are being pulled on each other. So watch this. We would take the I's. When we do U plus V, just like we talked about in the previous one, we would take the I's and we would add them together. In this case, we would subtract because one's negative. So 68.94 minus 60 is 8.94 I. And then we combine the J's. So J's are here. And when we do that, we would get 57.85 plus 103.92. It's 161.77 J. Okay? So this is my resultant vector. Awesome. So that's what we would get with the two forces. So what is the new magnitude and the new direction angle? That's the question. We can find that by just kind of doing a little bit of a sketch here for my resultant. So we would have it going to the right and up. So we'd be going here. Okay, we don't know what the magnitude is. So this is the, I'll call it W because I mean, it could be anything. We do use U and V, so we'll do W. So we're trying to find what the direction angle is. So what is this direction angle? And then also what is the magnitude of W? The new force that's exerted from our resultant, okay? So we could do this by going, okay, so 8.94. Over here, this is 161.77. And what we would do then is have a squared plus b squared. So it'd be the square root of 8.94 squared plus 161.77 squared. So here we go, 0.9. I love these, by the way. This is squared, perfect. Take the square root of this to get one. This is the resultant force pulled, 162.02. Okay, here we are. And then to find the theta, the direction angle, what I would do is I would just come back and say, okay, so to find it, I've got my opposite and my adjacent. I know tangent of my angle is equal to opposite over adjacent. Well, how do I get just theta by itself? I can then do the tan inverse. You could probably skip this step too if you kind of see it. that tan inverse of 161.77 divided by divided by 8.94 is equal to 86.84. Perfect. So my theta is equal to that there. Okay. But it's nice because you kind of can go step by step through it. And it's really just making sure that you hit each one and you answer each question. So it's much easier than just saying find the magnitude. You have the ability to kind of look and go step by step through that process. Okay. All righty. Man, we've gone through a lot here together. Let's see here. We went through that one. Look good on that one. Let's see this. I think we've done number 6, but I think I want to do maybe one more. Number 7, let's just talk through that one. I don't think that one's really tough. It says the figure shows 1,200-yard long sand beach, an oil platform in the ocean, angle made with the platform from one end. With the platform is 85 degrees, and then with the other end is 76 degrees. It's just a real-world application one of an angle side angle. So this would be an angle side angle, which would be a basic law of sines. And then it asks, trying to find what x and y is to the nearest 10th. So you would just say, okay, sine of 85 over y equals, then I would find this angle, which would be 61 to be 19 degrees. I think that's right. Yeah. So that'd be 19 degrees. So then we just say the sine of 19 over 1,200. This is yards. So then we could cross multiply and just giving you a heads up on how to do y here. 1,200 sine of 85 equals y sine of 19. So we would divide by sine of 19. The only thing I would say is just make 100% sure I do this first, then divide by sine of 19. Otherwise, it can be easy to mess that up there. So just as a heads up on that part. I think we did this pretty good on number 5, and number 6 was pretty good today. I want to do one more kind of angle side, which is number 3. Okay, so we could do number 3 and really number 4. So let's do number 4 since it's here. The question that on this one is, trying to solve for everything. And so if you don't have the triangle, the best thing to kind of note is to just draw it. So we got little a, little b across from big B, big C, little c. And what we've got here is we've got 3 things going on. We've got A, which is 57.5. We've got big A, which is 136. Right, so we have 136 here. And then 49.8, which is here. Okay. So the one thing we notice is that this is a side-side angle, largely because we can't go this way because it skips over 2. So we could say side-side angle, or, yep, I'm putting it on the podcast, angle side-side. Okay, so either of these would be the way that we would put it there. And with this one, that means we could have 1, 2, or no triangles. I'm going to put A, B, and C down here. There's triangle 1, there's triangle 2. If we got none, that means that we would get an error here. So just as a heads up on that, you would get an error if you were to mess that up on that part. So as we look at this, let's do the law of sines, where we do the sine of 136 over 57.5 is equal to the sine of, the only one we could do is here because we don't know B or big B or little b. So we'd say sine of big C over little c, which is 49.8. So we could cross multiply here to get, if I were to do it, 49.8 sine of 136 equals 57.5 sine of big C. Divide by 57.5, and then take the sine inverse there. Okay? Sine inverse of both sides. So on a calculator, I would do the top first. So 49.8 sine You put that all in. 49.8 sine of 136. We're good there. Then divide that number by 57.5. Just take it step by step. And when I do this, I get sine inverse of 0.601634. And so when I take the sine inverse of that, I get 37 degrees. Okay, so we'd say angle C is 37 degrees. Okay. All right, so let's come back. We know the given is 136. So if it's 136, that's the given one. We'll put that there. 37 degrees is here. As I look at this part, I notice that since this is the first one I solved for, its counterpart should be added up to equal 180. So 37 is subtracted from 180 to get 143 here, which then allows me to see, okay, what is the third angle? Now, this does not go side to side. Only the first one I solved for, right? First. And then the given is both, right? So just a kind of a reminder there. That's something people forget. So this would be 173. This would be 7 degrees, which tells me as I look over this right side, this exceeds 180. So there's no second triangle. But there is this idea of what am I still missing? With one triangle still out there, I need to solve for the side of B one more time. So we would kind of put this, I'll put it in blue here. So I would say, all right, sine of 7 over little b equals, and we'll kind of pull this back from earlier, sine of 136 over 57.5. We could cross multiply to get 57.5 sine of 7 equals b sine of 136. Divide by sine of 136 here. And we are Gucci, y'all. We are Gucci to go right there. So we got, I'll just kind of put it down. So 57.5 sine of 7 divided by sine of 130. Yeah, 9.2 something. Yeah, that sounds really low, doesn't it? I think because it's the sine of 7. Does sound low. Let me do this again. So 57.5 sine of 7 divided by parentheses. Make sure I put parentheses there. Maybe that was it. Yeah, 9.29 still. Maybe because this angle is so low. I did get 9.29. So B is equal to 9.29. I do want to check that. Let me make sure, double check the answer there. Because I did have that with me. Just double checking. Doo-doo. I don't know if I had that one down from earlier. I add that one to the list. Let me double check on the triangle calculator real quick because I do want to make sure that I did get that one right. Boom, boom. So hold up just for a second there. We'll go into one more. We have one like side angle side. I wonder if we've got one out there like that. Okay, let's see here. Where are you at? 36. That does kind of make sense. I just want to make sure because it's a little weird. Yeah, that's right. I mean, ish right. I mean, it's close because of the fact of how they were rounded. So yeah, that's actually true. That's actually true. It just seemed like the side length was so off. I wanted to make sure that I did that correctly. That's how we would do it. Number 3 would also be a angle side-side problem. So double check that one there. And just make sure you know how to do 2 triangles. Another thing too is if I did have a second triangle, you would have to do 2 side B's. So just kind of make a note of that as you're reviewing for the test there. We did the side one. This one's a basic law of sines one. That's there. Make sure. The only other thing that I would say is make sure you know the difference between side versus side angle side. Just note the difference there as you're preparing for it, and then you'll use the law of cosines. But on this one, I would be solving for an angle, whereas this one I'm solving for a side length. Okay. All right, sweet. Hey, I hope that was helpful for you. We literally, oh my word, we just rocked it. You all are awesome, and thank you so much. We'll keep it rolling one step at a time. We're almost to Thanksgiving break. Work hard, study hard, and know I'm here. I know Wednesday is going to be weird, which is tomorrow. So if I have you tomorrow, I apologize. I have the signing for a couple of people that I want to just kind of go to and support. So I want to do that. And then also on Thursday, I will be here. So if you need some help, feel free to come in as well. Other than that, we'll see y'all later. Have a great day.